And today we're going to look at something different, which is unsupervised learning. Throughout this course, we have been looking at unsupervised learning. That means we had a group of features with a target variable. And so we are predicting it. We're kind of mapping our features to predict the target variable. But for unsupervised learning, it's different. And this image shows what it's all about. But let us go through it before we explain what this image is all about. So basically, it's a new type, it's a different kind of machine learning algorithm, machine learning paradigm, sorry. And in this one, we don't have any target variable, we don't have any independent variable, what you have to predict. Like we said, there's no teacher to install the learning algorithm, there's no organization. It just you have the input data or the training data, and it just abstracts it and kind of extracts, get something meaningful from the data. So that's it basically. Like I said, it just shows the input data, and then it has to extract knowledge from the data. So that's basically what it's about. So with this diagram now, let me explain this. We can see we have this input data. We don't have any a target variable. And we can see we have different we have kinds of fruits here. We have watermelon, we have apple. Now we did not label this. We did not label it like that is apple, watermelon. So the machine learning algorithm does not know what is this thing is. So basically, we now build a model, and this model is now able to differentiate this. Okay, these ones are watermelon, these ones are, apple. So so basically, it runs a mapping based on the internal features of each variable we give it, and it will now create a mapping to kind of differentiate it and extract good knowledge from data. So that's basically what supervised learning is all about. It takes in an input data and extract knowledge data from it, based on the variables that are relative to a particular class. For example, um, the unsupervised learning is going to learn that, okay, watermelon is blue and apples are red, that kind of thing. So basically, there are many types of unsupervised learning, but the two most popular ones that are bedrock of every machine learning practitioner is unsupervised transformation and clustering algorithms. We're going to look at the latter in this course, and we're going to do some hands-on on it. But for unsupervised transformation, it's just basically kind of creating a new representation of data, kind of what do you call it, dimensional reduction. Like for example, you have 10 features and you want to like reduce it to 5, use unsupervised transformation. Like we said, and the common application of unsupervised transformation is dimension reduction, which take, like I said earlier on, it takes high dimensional representation of data, consists of information, and finds a new way to represent it or summarize it. So that's basically, there's some formal approach that we use. We use PCA, principal component analysis. We use TCNEA or non NMF. Then I'll put some link on this slide, so you can like get to know about this. But these are types of unsupervised transformation. We just take in an input data with 5 features, and we now like map it into 2. So it's very important. So you're now kind of abstract, kind of um stressing the main knowledge of the main data of the main data of the transformation. Like when when you have 10 features and you're reducing the features to let's say 5. Now the main points of the data is buttressed. It's a more emphasis, it's made more emphasis on. So it helps to avoid on overfitting. So most of the times, for a good machine learning project, you first do unsupervised learning to kind of emphasize most of the main points, the main the main importance of the data or the knowledge of the data. We first emphasize on it, and then we now do our supervised learning. So that's basically this is one of an advanced way that we do in machine learning. But the second one is custom algorithms. We're going to see and hands-on on this. It's basically a partition in the data into distinct groups of similar items. Like for example, we have this. Um, this is a type of costing. This is a type of a crossing algorithm, it's it's partition each similar data into its own space. So that's basically what cluster algorithm does. Um, like you said, example, consider uploading photos to social media and you organize your pictures. The sites might want to group together the pictures that show the same person. Now, basically, the site doesn't know the picture who doesn't know whether the person is you, but it's based on the similarity, is going to like group it and match it together. So we have a problem with it's a challenge we have with unsupervised learning, which is a little bit I'll say abstract, because there is no way we could evaluate the algorithm, like whether it's actually doing the right thing or doing the wrong thing. There's no metrics for unsupervised learning. We have to inspect it manually. For example, let's say because it doesn't contain any label information and everything. So let's say for example we group together each faces of different people or stuff like that, or this one we did. So how do we know that? How do we know that? Is there an average when we're training the algorithm? Is there an average that tells us, okay, this algorithm is learning well, is doing it does not. It does not have any average. So it's just doing it based on the numerical variables that it was given. It's not like abstract partition each size. Okay, this one. Okay, this particular feature has two. For example, use example. This particular feature has a red color and also has a green color. This one is a little bit oval. This one looks like a heart, like just type of stuff. So so that's what it uses. So there's no way to evaluate how our data is doing. So as I said, as a consequence, unsupervised algorithms are used as exploratory settings when a data scientist wants to understand the data better. That's why I said earlier on, when you want to do supervised learning, you do unsupervised to kind of understand the data to kind of abstract the main points or stress the main points of that the data is trying to point out. And like I said, it's explained there also. And when a new representation of data sometimes improve the accuracy of supervised learning. Yeah, so this is what unsupervised learning is. I hope you're getting accustomed to what how machine learning algorithms really work, supervised and unsupervised. Supervised learning is just the opposite of supervised learning. Is There's no class level, there's no target, there's no let's say there's no teacher trying to okay you're meant to map to what I am. So the supervised learning is just very free will. It could do whatever it really wants to do, but it is dependent on the fit the input data. That means the features that you give it, each of the numerical values, how it the features that it has. So that's how it groups or transform the data. So that's something you need to know. For an example of unsupervised learning that is very popular, I'm just going to say before I finish, is the Face app. If you remember the Face app that went global social in 2019 or 20, I think so. And that was unsupervised learning. Yeah, because it is they train the data with a lot of obviously old people. That was first app. When you put your picture, it shows how you be old in how you look when you get old, that kind of thing. So they train the data with old people's picture. So now the data now abstracted most of the major things that make someone old. Like for example, you understood those features, and then when you now put in your picture, it now like applies it to your picture. So that's unsupervised learning, because there was no target variable. It was just it was just it just gave it a data gave it the data and it learned about it and it knew how to apply it on things like that. So that's basically unsupervised. Unsupervised when it gives you that flexibility, they could you could train data for a particular purpose, and based on those features that it learned about that data, it could apply it somewhere else. So that's it for this course, for this session, sorry, and I'll see you in the next session.